Yes friends, so what we are doing here, we have to just do this question. So let me take, let A denotes event A, denotes the event of drawing a queen, right? And so this implies that an A number of A equal to 4, therefore probability of A will be 4 upon 52, and NS total number of cards 52 initially, so this is NA upon probability of A is NA upon NS, 4 upon 52, this means 1 upon 13, no problem, 1 upon 13 it is, first case. Second case, let B denotes drawing a king, so N B, number of favorable cases in B is still 4. Why? Because 4 kings are there, but NS in this case will be 51. So now cards left are 51. One card is initially drawn, is not placed back into the playing cards. Okay, so that is what NS is. Therefore, probability of second case B, probability of C is 4 upon 51. Okay, not cancel out. This is second case. Let C denotes the event of drawing a jack, or knave, right, of drawing a jack. So this is equal to how much? Again 4 jacks are there still, but cards left are 50. So initial event was 4 upon 52, second is 4 upon 51, third event is 4 upon 50 now. But now cards 1 decreasing. In these 3 events, these are 3 events here. What is this probability? How to be define this? This is a compound event here. Therefore, probability of A intersection B intersection C, compound event. This is compound event. Hence, the compound event, this is a compound event here. Probability of A intersection B intersection C is equal to probability of A into probability of B when A has occurred already, into probability of C when both A and B have already occurred. Compound event. So this can be put as 4 upon 52 into 4 upon 51 into 4 upon 50. Okay, this is the total value. Let me calculate this finally. Answer. So this compound event, hence probability of A intersection B intersection C, compound event, this is given by this formula. This is 4 upon, let me again write, probability of A into probability of B oblique A means with respect to A when A has already occurred, then B is occurring, and probability of C when both A and B have already occurred. This is given as 4 upon 52 into 4 upon 51, okay, into 4 upon 50. Now let me solve it. In the second question also it was the compound event. We have to denote that in this way. Okay, so 4 upon, initial was 3 upon 8 and then 2 upon 7, multiplied the 2 events. That was also the second question, was probability of A intersection B equal to probability of A into probability of B upon A. Probability of A was 3 upon 8 in the first case. The total balls were 8 in the second question. 4 upon 3 upon 8 into 2 upon 7. That was also compound event. That was up to only this probability of A into probability of B upon A. Probability of B upon A is the condition probability. Okay, now because in that situation, compound event we have to calculate in this case also. This is a compound event. Now let me solve it. Sorry. Let me now finally solve it. It gives us, this is 1 upon 13. Okay, this is not cancelled out. This is 2 upon 25. So let me take 4 to the 8. Yeah, in the denominator. 4 to the 8 divided by 13 into 51 into 25. So 25, let me multiply first 25 into 51. It is 13 into 51 into 25. This will give us 8 upon 25 into 51. This is 25 into 25, 5. To carry 25, 5 ja 125 plus 2, 127. Now into 13 also. Into 13. So this is finally 13 5 is 65. Let me take 8 upon 13 5 is 65. 5, 6 carry. 13 7 ja. Right? How much? 65 plus 13, 78. Yeah, 65 plus 13, 78. Sorry, this is 7 times. I'm sorry, this is 91. Well, 13 5 just 65. This is 7 times, not 6 times. 37 just 91. This is the 7th year 21. This is 1. So 91 is there. 91 plus 6, 97. 7 here, 9 carry. 13 to the 26. 26 plus 9, 35. 5, 3 carry. 13 1 ja 13 and 3, 36. So 16, sorry. So 8 upon 16, 5, 7, 5. 7, yeah, 5. So this is the answer here. This is 8 upon 16, 5, 7, 5. Now this is prime factor to each other. Always be right. Either we can find decimal also, 1 point something. Okay, so then just find out that in decimal also we can calculate. But in this case, the proper value is this. Okay, because this is prime to each other. This is the least ratio prime to each other, these numbers, because this is 8 even number. This in the denominator we have odd number, not cancelled out. Okay, this is how total answer is. So this answer is of probability compound event. This is compound event is calculated with respect to probability of A into probability of B by A, probability of C oblique when A and B have occurred. That means A intersection B in the denominator. This is the compound. So secondly, similarly, the second question was there, compound event. Okay, so this is what we define the compound events with the help of condition probability. Okay, so in multiplication of condition probability of the event given, we find the compound event A intersection B, or probability of A intersection B intersection C if there are 3 events, or if there are 2 events, then probability of A intersection B. We just calculate that. Now question number 4. Now what is question number 4 say? Let me first read it and then solve it. Okay. Okay, now question number 4, what does it say? Let me check it. Question 4 says a pair of dice is rolled. Okay, if the sum of 9 has appeared, find the probability that one of the dice shows 3. One of the dice shows 3. Now probability that one of the dice shows, okay, so pair of dice is rolled, the sum of 9 has appeared. Sum of 9 has appeared. This is the first event A. Then this first event A has occurred. Okay, out of the total events, total outcomes 36, because one pair of dice is thrown. Okay, so total outcomes are rolled. Total outcomes are 36. Out of that, I would say the sum 9 is noted down. Which are the pairs which are showing sum 9? that are noted down. Now it says that find the probability that one of the dice shows 3. So the sum 9 showing those pairs, out of those pairs which are showing one at least 3. The digit 3 showing, one digit 3 showing, one of the dice shows 3. Those outcomes are how many? Okay, that is event B, which is occurring second time. Okay, now let me check. A pair of dice, it says a pair of dice is rolled, right? Is rolled if the outcomes, and the outcomes, let me take, and the outcomes, and the outcome of sum 9 has appeared, then find only those outcomes which are showing 9 sum. 9 sum has, okay, outcomes, and the outcome and outcomes of sum 9 has appeared. Outcome of sum 9 has appeared. Let me take outcome only. Sum 9 has appeared, or some outcomes of sum 9 have appeared. Now to find the probability, now try to understand this question here. Find the probability of one of the dice shows 3. One of the dice shows 3 means the sum 9 is noted down. So which are the sum 9 showing outcomes? Those outcomes are, let me take sum 9, because it starts from not 2, 6, no, 3. From 3 it shows 3, 6, 6, 3. And there will be 4, 5, 5, 4. These are the 4 outcomes which are showing 9 sum, right? Others are not there. Only 4, 5, 5, 4 and 3, 3. But we have to take those dice or those pairs which are showing one dice shows 3. So there are 2 outcomes, 3, 6 and 6, 3. Alright. So here B event is solution. Let me take here event A. Here event A denotes the outcomes of sum 9, right? Of sum 9. So A is the sample space. Which are those sample space? First is 3, 6, then 4, 5, 5, 4 and 6, 3. Only these are the 4 outcomes. Try to understand this point. These 4 outcomes are showing sum 9. Well, 5 plus 4, 9, 4 plus 5, 9, 3 plus 6, 9, 6 plus 3, 9. These are the 4 outcomes only, no other than these 4. This is A event. A is having this implicit and A number of favorable cases in A is 4. This is 4 here. And B denotes, now B denotes only 3, 6 and 6, 3, which shows that one dice shows 3. These are the 2 outcomes which have sum 3, sum 9, but one dice shows 3, 3, 6 and 6, 3. These 2 outcomes are there. And B, this is bracket, and B, number of favorable cases in B is 2 only. So what is the probability of these 2? Let me just find out them. So probability of B with respect to A. Therefore probability of B with respect to A is equal to, first let me take NB upon NS, NB upon NS upon NA upon NS. Important. So first this was 2 outcomes only. in B. So B, or we can say that NB upon NS. This is this is NA intersection B. First is A intersection B. I'm sorry. This is not NB. I'm sorry. This is NA intersection B. Okay. NB undoubtedly is 2. But what is NA intersection B? Out of these 4 and 2, only 2 are out. 2 are common between A intersection B divided by NA. This can be written as NA intersection B oblique NS upon NA upon NS. Total outcomes. So what would this? So this gives us what's common between A and B are only 2 outcomes. This is 2 upon 36. And in the A, there were 4 outcomes, only 4 upon 36. 36 cancel out. This is 2 upon 4. And this is 1.2. This is the answer here finally. So this is condition probability. So condition probability is outcomes in the A intersection B, A and B. What are the outcomes between them? Common. 2 outcomes were common. For 3, 6 and 6, 3. Out of 3, 6, 6, 3, 4, 5, 5, 4. These 2 were the common here. So N, A intersection B divided by NS. This is definition of probability. We can divide by NS. This is probability of A intersection B upon probability of A. The probability of A intersection B is 2 upon 36. This is 4 upon 36. Only 2 upon 4. That means 1 upon 2. Final answer. Question number 4 is based on condition probability undoubtedly. Okay. Let me take next question. Now question number 5. So condition probability is based on dependent events. When one event A happened first, then B was occurring, then condition probability of B when A has occurred first is given by A intersection B, probability of A intersection B divided by probability of A in this case. Now question number 5. What is given to us? Let me first write it down. Here we are given. It says that 3 fair coins are tossed. If the first coin shows a head, find the probability of getting equiprobable sample points as shown below. Okay. So out of this equiprobable sample point means showing the heads only. That event we have to find out. Find the probability of equiprobable means equiprobable points. That means only the heads. First heads appearing, those events are to be noted down. This is A event. 3 coins, 3 fair coins. Let me write here. 3 fair coins. 3 fair coins are tossed. Then it says 3, and if the first coin, this is the event A, the first coin shows, a head. This is the event here. Shows a head. Okay, then find here the probability. Find the probability of getting equiprobable. Find the probability of getting equiprobable sample points. Equiprobable sample points. Equiprobable sample points as shown below. These are the all outcomes. 8 outcomes are given. Okay. So let me just find out what is sample space here. Solution. See here that here S equal to, now because the 3 coins are thrown or tossed, so this is HHH, HHT, right? Then HTH, THH, two heads, three events are there. Then one head, HTT, THT, TTH, and TTT. Here the total 8 outcomes. Sample space. Where NS is, this implies that NS equal to 8. Total outcomes are 8. What about the A event? Where it says the head is shown first. Head is shown first. They say that if the first coin shows head, that is the point. So which are the event? One event, second event, third event, this fourth HTT only. First, so there are the 4 outcomes here. So first A event denotes here. Let me write from this solution. Here A denotes the first. Now this fair coin toss, if the first coin shows A head, denotes the, okay, A denotes the first head, first coin shows head. First coin shows head. That is being denoted by event A. That means those outcomes are HHH, HHT, first head. Okay, first 2 are showing head, no problem. But at least one head must be there. First showing head, and then HTT. Okay, these 2 heads, 1 head. This is the first head showing. Okay, these 2 and this 2 first head, first 2 heads, first 3 heads. Okay, only these 4 outcomes are there. A denotes these 4 outcomes. Now what is the B outcome? And B denotes the second event, of heads only, equiprobable heads only. That means only heads. B denotes the second event which has only heads. Equiprobable means here only heads. Heads. First shows head, then other also shows head, third also shows head. Equiprobable means the same kind of event is occurring with all the 3 coins. That is what. So B denotes only one event which is HHH. Equiprobable event is only one event. So this is NB is equal to 1. NB is 1. NA is number of favorable cases in A is 4. 1, 2, 3, 4. First coin shows head. Now it says equiprobable means all the coins shows head. This is only one event where all the 3 showing head. So this NB. Therefore, conditional probability of B when A has occurred first is equal to NA intersection B upon NA. Or we can say probability of A intersection B divided by probability of A. What is A intersection B? Only one common. So 1 upon 36 divided by 4 upon 36. A event is, this is 1 upon 36. Probability of A intersection B means one common only in A and B. Divided by 4 upon 36. 36 cancel out, this is 1 upon 4. This is the answer here. Okay. Question number 5 is finally completed. Question number 5 is done. Okay. And question 5 is completed. Let me take now question number 6. So conditional probability depends upon what kind of question is being asked. If compound events are there, then we take probability of A intersection B, that is compound event. Both events are taken together. Okay, that is in case of dependent event and outcome. Question number 6. we are given. Let me take what is given to us. The question number 6 is this. It says a bag contains 4 white and 6 red balls. 2 draws of 1 ball each are made without replacement. Then it says what is the probability that first one is red and other is white. 2 balls. This is first question, first part. Both the balls are red. There are 2 events here. Again compound event it is. When the first draw, the first ball drawn is red in the first part and other is white. So how many white and red are there? So 4 white and 6 red balls. Undoubtedly we can find out. This is a compound event we will calculate. This is what we are given. A bag contains, it says a bag contains 6 red, look, 4 white and 6 red. This is 4 white and 6 red balls and 6 red balls, right? Now 2 balls, it says 2 balls are drawn. 2 balls are drawn. Okay, one after the other. 2 balls are drawn. 2 draws of 1 ball each and each. 2 balls are drawn one after the other. One after the other. This is the point. One after the other consecutively. 2 balls